Give me those mole problems. That's what you're saying right now. I know that it is. I know that you can't wait to start solving these problems because you're so comfortable with them now and you're ready to prove to me what you do know. But before we do that, really, I want you to go through some more examples just so you can feel more comfortable with it. So let's say that we have 3 moles of sodium in the lab. How many grams is that? All right. So if we do this problem, we're going to do it just like we finished our last video. I'm going to take the number that they give me in the problem, 3 moles over 1. In the next step, mole on top, mole goes on the bottom, and I need to go to grams of sodium. In order to go from grams to mole, or back and forth, we said we need formula weight, because formula weight tells me how many grams there are in 1 mole. Well, this is just sodium, right? So that means if I go to the periodic table and I pull up sodium, which is right here, that's 22.99. That's all there is to the molecule. That's it. That's the formula weight, people. It doesn't get any simpler than that. That is the formula weight for sodium. It's just Na. So 22.99. That's basically what I need to use. So 22.99 grams for every 1 mole of sodium. So to solve this problem, I would take 3 and I would multiply that by 22.99, and that gives me 68.97. And that is in terms of grams. So if I need 3 moles of sodium in a laboratory, I need to measure out 68.97 grams of stuff to use, right? That's all there is to it. All right, let's do another one. Second example. Let's say that we have 5 moles of magnesium. How many grams is that? Take my number that they give me, 5 moles over 1. In the next step, mole on top, mole on the bottom, and I need to go to gram. Well, I need to go to the periodic table and I need the formula weight for magnesium. And it's just Mg here. That's all that we need. So I do the same thing I did before. There's magnesium. 24.31 is what this is going to round off to. So 24.31 in 1 mole. So I bring out my calculator. I'll do 5 times 24.31, and I get 121.55. So if I need 5 moles of magnesium in a lab, I'm going to weigh out 121.55 grams of that stuff and bring it over to my lab bench so I can use it. Next, what if we needed a half of a mole, 0.50 of Cl2? It's chlorine, that's chlorine gas, right? Well, I do the same thing. I take my given, 0.500 moles over 1, mole on top, mole on the bottom, and I need to go to gram. I need to figure out how much is there. So I'll go to my periodic table, chlorine right there, 35.45, and we got 2 of them. So 35.45 plus 35.45, that's 70.90. So 70.90 grams in 1 mole. That's the formula weight. So I'll take 0.5 and I'll multiply by 70.90, and I get 35.45 grams of chlorine gas that I should weigh out. Okay, so let's do another. And I'm going to clear this screen off. Well, if it will let me. And we're going to take a 4th example. And this is going to be 0.250 moles of MgCl2. All right. So just like before, I'll take the number that's given, 0.250 moles over 1. and then I bring in my dimensional analysis step, mole on top, mole on the bottom, and I need to go to gram. So I need the formula weight for magnesium chloride, MgCl2. So I'm going to bring up my calculator. I'm going to find Mg. Mg is right there, 24.31. And then I've got 2 chlorines. So I'm going to come over here to find chlorine. That's 35.45. So 35.45 is 1, and 35.45 is my second. So that's 95.21. That's the formula weight for magnesium chloride, 95.21. So formula weight goes here in 1 mole. So 95.21 grams for every 1 mole of magnesium chloride. Well, if I only need a quarter of a mole in the laboratory, 0.250, I'm going to multiply that by 95.21, and I'm going to get 23.80 grams. So 23.80 grams. If that's what I weigh out in the laboratory using a balance, that represents 0.250 moles of magnesium chloride. Okay? All right. Well, I'm going to keep going, and I might do 1 or 2 more examples, and we're going to look at E. And this one is going to be 3.50 moles of calcium carbonate. All right, so 3.50 moles of calcium carbonate over 1, mole on top, mole on the bottom. I need to go to gram. Well, in order to do that, I need the formula weight for calcium carbonate, CaCO3. There's my periodic table. I'll find calcium first, which is right there, 40.08. So there's my Ca. The next one is a carbon, so 12.01. And then O3, CaCO3, right? So I've got 3 oxygens in total. So there's 16, 16, and 16. So the formula weight is 100.09. So 100.09 grams in 1 mole. There's my setup. Only thing I have to do now is bring up my calculator and solve the problem. So 3.50 moles times 100.09 grams. So if I need 3.5 moles of calcium carbonate for a lab experiment, then I'm going to measure out 350.32 grams of stuff. So 350.32 grams of calcium carbonate. All right, and I think that that's pretty much all that we need to talk about as far as converting moles into gram, right? That's the focus of this lecture, and that's all that we've done. We've went from gram to mole, or vice versa at least, mole to gram. So I'm going to turn you loose on an assignment, and the assignment is going to be a series of problems, and these are the types of problems that you will see. It will say, this is how many moles are needed for the experiment. How many grams would you have to weigh out? And you would have to do the simple calculation in order to find the total number of grams. And then in the next set of videos, we'll flip it so that way you feel comfortable or more comfortable about going backward than what we've done in these examples. All right? So now that you finish these 2, tackle the assignment, complete those problems just like what we've done here. Mimic what I've done, and I think that you'll feel more and more comfortable with these calculations as we go forward. Okay, so good luck, submit your answers, and then tackle the next set of videos and the next assignment.